So today I would like to talk to you about how to use microservices on AWS using services like AWS Lambda and using our services to manage Docker containers. So microservices is quite a trend recently. It's a different way to implement your own application, so you don't grow your application to be a big monolithic source of code, but you split it into smaller parts. And for each part of your application, you have a different service that can use a different technology stack. And usually you want this part to be small so that if you want or if you need, you can rewrite one of these services that is building up your application in less than 2 weeks. In this way, if you have a new requirement, you find which services are affected, and if there is a service that is really affected, it's difficult to implement a new feature, you can even rewrite it from scratch with a new different technology stack. So it's a completely different approach. Not only on the technical side, there is an organizational impact of microservices, but today I want to focus on the technical side. So how to use AWS to do this kind of architecture in an easier way. So why AWS Lambda? We announced AWS Lambda last November in reInvent, our conference in Las Vegas. So AWS Lambda is an event-driven, fully managed computing environment. What does it mean? It means that you don't need to care about the infrastructure. You just need to write a function, and you can upload this function to AWS Lambda, and we will execute the function based on events. And we will automatically grow and scale the execution environment for this function. We will manage scaling. We will manage the deployment of the function. We will manage high availability, monitoring, and logging. You just need to give us the code. So the automatic scaling is completely managed under the hood, so there is no visibility like you have for the traditional EC2 autoscaling when you know there is a specific number of instances. It's just that if there are more requests in parallel, we automatically add resources to that. And you pay with a very fine-grained model. So you pay by the hundreds of milliseconds and the number of executions. So if your function is lasting 800 milliseconds, you pay for those 800 milliseconds of execution. And there is also a very generous free tier if you use AWS Lambda. Every month, for every user, not just new users, so for every user, you have 3.2 million of seconds of execution time if you use the small 128 megabyte RAM environment, and 1 million of invocations. So I talked about events. So Lambda functions are triggered by events. So these are the source of events that we currently support. We say that we are going to extend this. So it seems there is some flickering with the screen. Maybe the cable. No, we lost it. So I didn't improve, I think. Okay. I tried with disconnect and reconnect. So these are the events that we support, and we said we are going to support more kind of events. For now, we support S3 events. So if you add an object or if you modify, because for S3 is a copy of an object on S3, we can send an event to Lambda. DynamoDB streams is a stream of events that tells you any change to a table in DynamoDB. DynamoDB is our fully managed NoSQL database. Kinesis, our streaming service, so it's a service where you can stream data. I think we have to, I can try to lower the settings for the screen. Boo, 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 boo. Maybe this is better. So Kinesis is our streaming service where you can collect information and send information from a distributed environment. You can use it for a log collection, or you can use it for an Internet of Things or Sensors platform. Or custom events. Custom events, it means that you can trigger a Lambda function using the Lambda API. So you can call a Lambda function from a script, but you can call it from a JavaScript client-side application or from a mobile application. So I understand that everything seems a lot theory now, but when we will see the demo, it will be much clearer. So this is one side that we will see in the demo, the Lambda functions. The other side is Docker containers. Does everybody here know what Docker is? More or less. Okay, so I will be quick. So on Docker, you have a different kind of virtualization. So traditionally, with virtual machine, you have a physical server, a host operating system. On top of that, you have a hypervisor that will create a completely virtual hardware environment, on top of which you install a guest operating system. On the container side, the host operating system will create a virtual environment sharing the kernel of the operating system. On top of that, you create a container where you have all the user land space part of the operating system. So the system libraries, the user libraries, and the user application. But the kernel is shared across the containers. So you can see that the container side is much lighter than a traditional virtualization. Actually, containers are not really new, because containers started with the BSD jails more than 10 years ago. Then Solaris implemented the Solaris container. Linux implemented containers in different way. Docker, what they did is they created a very easy to use and developer-oriented management platform for containers. So this is really what Docker did and make containers more popular. So with containers, you see everything is much lighter, much faster. But of course, the security and the isolation across containers is not at the same level like a normal virtual machine. So you have to make a compromise, because there is a single kernel that is shared. So if you want to use Docker containers on AWS, you can use them just on Amazon Linux or any Linux distribution that supports Docker. You can use our Elastic Beanstalk service that allows you to quickly deploy an application. Usually with Beanstalk, you give us source code. You support Java, PHP, Python, .NET, a lot of different platforms. But we support also Docker. So you give us a Docker container, and we create automatically a scalable environment. What we announced last year in November, in the same day, if I'm not wrong, as AWS Lambda, is Amazon EC2 Container Service. This is a new service that allows you to manage containers at scale. What does it mean? It means that and this is what we will use in the demo today. So with EC2 Container Service, you have these four main components. So you have container instances. These are the EC2 instances that we will use to deploy and use Docker containers. These are plain EC2 instances with the Docker daemon and the Amazon ECS, so the corresponding agent running inside these instances. And the Amazon ECS agent, it's a Docker container itself, and it's open source on GitHub, so everybody can look at it and improve it. This instance with the Docker container will automatically register to a cluster. So all these instances can be part of a single cluster, or if you want, you can create more than one cluster. And the cluster are like a resource pool. A resource pool where when you schedule the execution of a task, we will try to find the best resources inside the cluster to execute this task. And what is a task? A task is a group of containers. So the task is not a single Docker container, but can be more than one Docker container. And is defined by a task definition with a JSON syntax. So let's see now something more practical. This is the task definition for a task that has two containers. The container on the left is a WordPress stackable container, so it's the application side of WordPress. I assume everybody knows more or less what WordPress is. On the right is a MySQL container, and so it's the database. So this task is creating a two-tier application with two containers, WordPress, the application side, and the database side of MySQL. So on the right, we see the definition of for the container running MySQL. So the image is taken from the Docker Hub. So any syntax that the Docker Hub is using, you can grab it. So in this case, it's the default MySQL image. Then you can specify how many CPU and memory you want to give to this container. And the units for the CPU are very small, very granular, because 1024 means one core visible on the container instance machine. So in this case, you are giving 100th of a core to this container, so very little power. Memory is in megabytes, so 500 megabytes. And then you can pass environmental variables. This is very nice because it's the best way to customize the execution of a Docker container. So you can create a flexible Docker container that a startup will read some configuration from environmental variables and then run. In this case, for example, you can pass the root password of, so the password of the database in an environmental variable. You will give the same password to the other container so that they can talk to each other. And then if you need to export outside of the task, let's say externally, a port where the service is exposed, you can use port markings. In this case, you don't need to use it because in this case, we use links. So from the top, you see there is the image, in this case is WordPress. We have the essential parameter. Essential means that this part of the task, so this container is essential to the execution of the whole task. So if this container fails, all the other containers that are part of the same task makes no sense, so you have to terminate the whole task. And this is, of course, true in this case, because without one of the two parts, the architecture doesn't make sense. If you have, for example, two application servers, then they are not essential anymore, because if one fails, you can replace it with another. The links allows you to let two containers communicate without having to export a port. So in this case, you say, I go back, the DB was the name. You see the second line of the MySQL container. You see there, and DB, I say this front-end container, WordPress stackable, is connected to the DB container. So in this case, you can reference inside the container DB as an host name, and automatically Docker will remap it to the other container. And here, this is the web interface of WordPress. We have to expose port 8. So the container port is 80. And the host port is the same. In this case, is 80, so you expose WordPress on the port and the normal HTTP port. So this is the way in which you can define a task, and then you submit the execution to the task to the scheduler of ECS, and we will find inside the cluster the best resource where to execute, depending on the CPU and the memory that you ask all the components of the containers. So what it means that now you have really different options to use. So developers, they started with on-premises architecture, where if you need to add resources, you need weeks of time. With Amazon EC2, you need minutes to start a new virtual machine, a new instance. But with containers, you really need a few seconds to start an instance, so it's making the development much faster, especially in the early stage of development. And with AWS Lambda, you go into the millisecond space, so you really have a different speed. And what we see is that developers, they are able to use this speed in their mindset to implement new things, new features. So it's really interesting. So let's see now a demo architecture that I think will explain all that I said much better. It's a very simple demo. It's like a prototype of a content management system. And I'm using a static site to generate a content management system. So let's imagine that you have a few images, and this image, they have some metadata, like the title, the author, maybe a description, maybe a list of tags that describes these images. And then on the right, you have the architecture inside AWS. You have a first bucket that you will use to host these images, a Lambda function, a second bucket, now we will see why, a DynamoDB table that I will use to host the metadata of the images, and ECS to execute a task. So the first thing that you do is you upload the object, so the image, to S3, and use S3 metadata, the S3 custom metadata, to host the metadata of the picture. S3 has the possibility to add to an object custom metadata, so I use this feature just in a passive way, so that together with the object you have the metadata on S3. But now I use AWS Lambda. So this put object on S3 will trigger an event notification to Lambda that will execute a function. This function will do three things. The first thing is to create a thumbnail of this image. So because usually in a website you want to create a thumbnail to show the picture in an index. The second thing, it will extract the metadata from S3 and insert the metadata into a DynamoDB table. And the third thing will run a task on ECS, and this task will be scheduled very quickly on the ECS cluster that I prepared. It's just two instances, two T2 micro instances, and there a Docker container will start and will read all the images that are in the DynamoDB table and build an index.html page that will be uploaded on the second S3 bucket. So at the end, the second S3 bucket will have the thumbnail and a new index built on top of the images. So one question, why do you think I use two different buckets and not a single bucket in this architecture? Sorry? Yeah, otherwise I would create a loop, because when I generate the thumbnail, if I write the thumbnail in the first S3 bucket, it will generate another event and trigger the Lambda function. Of course, I can use different paths, and I can put in some logic in the Lambda function so that if it's a thumbnail, I ignore it. But I will still pay for the few milliseconds of execution for this if. So since now I can really fine-tune my application in the milliseconds, it's much better, and you don't have any additional cost to run it this way. So it's everything clear in the architecture. I can pass to the demo. The container ends. Can you read the screen? Okay. So let's go into this directory. So I clean a little bit the directory so that we have everything. So this is the Lambda function. It's an index.js file. And for now, we only support Node.js as the execution language for the function, but we are going to grow. We are planning to add other languages in the future. And of course, we are basing this on the feedback that we get. Actually, you get a full Linux environment when you execute a function. So there are customers that they use Node.js only as a wrapper, and they bring their own executables that maybe are written in C, C++, or binaries built with Go, because Go will build a binary, and so they already use Go in Lambda using Node.js just as a wrapper to execute a binary. So if you see here, we have this is the syntax of JavaScript, so maybe not everybody is familiar, but this is the part where you import the external modules. So we have a few dependencies here, the async module, the GM module for the thumbnails generation, and the AWS SDK. Here's some configuration like the name of the bucket, the name of the DynamoDB table. This is the size of the thumbnails. I was very lazy, so I put it into the code. I could have done something much more better, probably. And then you have just the function that you are exporting. So here you export as with the name handler a JavaScript function. So if you want, you can use the same function locally and test the Lambda function locally. You don't need Lambda to test it because it's just an Amazon Linux environment. So almost a plain Linux environment. So the things that you do, you get from the event that we pass, there is a specific syntax that you will see, the bucket name and the object key of the object that has been inserted. I compute the name of the destination bucket as the same name as the input bucket plus dash resized. And I also add resized at the beginning of the new key. If the buckets are the same, I give an error because I don't want to do that. I check that the object is actually an image, and if it's not an image, I don't go on. And then I use the async module to execute a few steps one after the other, because JavaScript and Node.js, it's an asynchronous language, so if I don't use the async module, everything will go in parallel. So that's why I use the async module. So I download the image from S3, then I transform the image to create the thumbnail. I upload the new image to the new bucket. Then I read the metadata from DynamoDB, from S3, and I write it on DynamoDB with a put item. And then this is I I have into a local variable the name of the task. This is to execute the task on S3 that will rebuild the index.html page for the images. This is just to handle any error. So if I want to upload this, I need to add the dependency. So I use, in this case, npm for a node to install async ngm. I don't need to install the AWS SDK because we already provide it into the Lambda environment. So the modules are into this node modules directory. So now I can zip everything into a zip file. So I created a zip file. This is process new content.zip with the Lambda function and the node modules directory. And now I can go in the Lambda console, get started, and create a new function. So how did I call it? Process new content. So let's keep the same name. You can upload, you can work with the code inline, but in this case I need to bring also the modules, so I need to upload a zip file. So the zip file should be here, no, on the desktop. This is the name of the file. I use index.js because I'm very lazy and it's the default, but you can change it. The name of the exported function. And from the security perspective, Lambda is very interesting because you have two roles. So in AWS, we have the identity and access management allows you to give role to a resource inside AWS so that they can do different things on other services. So with Lambda, you have two different roles. This is the execution role. So this is the role that the Lambda function will assume to execute its work. So in this case, I need the capability to read from one S3 bucket, to write in the other S3 bucket, and to write into that specific DynamoDB table. So this is a YAM role that will give this ability to the function. The other role that we will see is the invocation role that I will need to give to the S3 bucket. So the S3 bucket that will trigger the Lambda function needs to have an a role that allows him to execute the Lambda function. In this way, you decouple the two roles. And it's interesting because if you have a JavaScript application that is launching Lambda, you don't need to give powerful role to the JavaScript application that lives outside of AWS. You just give the capability to run the Lambda function. So in this case, I prepare the role here. And this is what gives a difference in the pricing. So you have to decide how much memory you want to give to this function. The minimum is 128 megabytes. The maximum is 1 gigabyte. So in this case, I know that I don't need a lot of memory, so I use 128. But the pricing is linear to the memory. So if you use double the memory, the pricing is the double. So the unit is 100 milliseconds, and then it depends on the memory. Then there is a timeout to avoid that you launch a function and for some errors and you enter into a loop and you continue to pay for this Lambda function that is executing in the background. So in this case, I use 10 seconds. For now, the timeout is at maximum 60 seconds, but we are planning to increase it depending on, so that you can also handle more long tasks. But for most use cases, you don't need a lot of time. So now I created a Lambda function. And the Lambda function is created, but it's still not attached to any source event. So I need to go here and configure the event source. So in this case, it's an S3 bucket, so I can do it from here. So I select the first bucket that I know. In this case, I called it in this way. And here I have to go to give to this bucket the invocation role, so the capability to trigger the Lambda function. So I submit here. OK, congratulations. Now the event is connected. So now we can try to see if everything that I said, it actually makes sense. So this is the first bucket. Let's upload an image here. So I downloaded a few pictures here. So let's go here on the castle. I can add this file, but in the metadata here, I will add the custom metadata with the title and this thing. So I use this specific tag, and this part I call it data, but it's something custom that you can decide. And here I should have This is a JSON syntax that I invented, so something custom, so title, author, description. So in this case, I just put it into a single line, copy, and paste into S3. Now I start the upload, and the picture has been uploaded. If we go back to the Lambda function, it has not been triggered. Let's refresh. Probably I made some. .conf demo. Not working. I did something wrong. No, okay. The first execution can be a little bit slower than the others. Here we can see using CloudWatch logs the execution log. So this is the log for today. And it was executed, and I see a success here that it's a very good sign. And here you have the report of the execution that tells you how much the function ran. The first execution is usually slower because you need to load all the dependency, and you know how much you have been billed. This is the memory that we give, but we actually use only 49 megabytes. So if you give more memory, you can see here the log and understand if you want to give less memory. So this is the first bucket. This is the second bucket. Let's reload. And as you see, we have the resides castle and the index.html file. Now if I open this file, this is what was generated. So the thumbnail, the metadata that was extracted, so the title, the author, the date was actually taken from the S3 object itself when it was uploaded, and the list of the tags. So now what I can do, I can go on the first bucket and add all the other image that I prepare at once. So this is the list. And the metadata, oops, here. I will add for now, the same metadata to all the objects. So now I'm uploading other files, and if I go here on the other bucket, I will start to see there is some delay. But we can see also here the execution of the Lambda function. Okay, so we see that there are more execution. Okay, you see all the resized image and the index. So if I go here on the image and I refresh, now I have, I have all the pictures with the description. So I was very lazy, so you see the description are the same for all the pictures. So what I can do, I can go on the first bucket. This is the castle. We go on the properties. We see the metadata. Of course, I'm doing that here, but you can do that programmatically in a much better way. I can change the title. This is the Budapest castle. Correct me if I'm wrong. And I save it. Now if I go here, this is the Liberty Bridge. And I save it. Now if I go on the page, you see it has been updated. Budapest Castle, because when you update the metadata, it generates new events. So if you think there is no running part in this application, everything is just there waiting for events. When you do something, the events are triggered. It's like a spreadsheet. When you change the value of a cell, all the cells that depend on that will be updated. So it's event-based architecture, and the cost of this architecture is very low because you don't have running parts. You have only things that are waiting for something to happen. So that was my demo. I hope you found it a little bit interesting, and if you have any question, please ask, or we can talk later. Maybe let's give more space to the other speaker.